This week, self-piloting ships, fighting COVID-19 with disinfecting drones, and finding the best bang for your buck in photovoltaics. In solar energy, everyone from electric utilities to homeowners are installing photovoltaics, inverters, and batteries to enjoy that free energy from the sun. Well, the sunlight may be free, but the technology to capture it, store it, and turn it into usable AC power can be very expensive. Which panel technology is best? Should the panels include tracking systems? Is it more cost-effective to use all available technology or just upsize a simple system? Every homeowner or small-scale user contemplating solar has these questions, and this week Tom Lombardo addresses that issue. He reports that a recent study in the industry journal Joule analyzes the yield potential and cost-effectiveness of bifacial photovoltaic panels, fixed tilt mounts, single-axis trackers, and dual-axis trackers to see which combination of technologies offers the most bang for the buck. Now, professionals in the industry, of course, they have a technical term called levelized cost of electricity, a sort of reciprocal of the bang for the buck concept. Now, in this, lower numbers are better. The study used data from a variety of locations, cross-referenced variables, and then validated initial models and ran simulations. Not surprisingly, the Cadillac solution, bifacial models with dual-axis tracking, well, that delivered the most total energy. But when cost is factored in, the research determined that for more than 90% of the analyzed land area, and those are regions within 60 degrees of the equator, well, the lowest levelized cost of electricity comes from bifacial modules with single-axis tracking. Now, of course, the sun arcs from horizon to horizon higher or lower depending on the season, and single-axis tracking can't compensate for this. But the study showed that tracking is the single largest factor that affects yield. But given the option between expensive bifacial modules and single-axis tracking and cheaper panels with dual-axis tracking, it's more cost-effective to pick up the reflected solar energy than present the forward face of a monofacial panel to the sun optimally. Now, as they say in the car commercials, your mileage may vary, and albedo is inconsistent across the planet, but the test results show a definite effect, although small. Tom reports that for every dollar spent on a monofacial panel, you'll spend 97 cents to get the same amount of energy out of a bifacial module. Now, that's not going to switch an off-grid prepper in Alaska, but it's real dollars to those big utility-scale projects. We're looking forward to more reports from Tom on real-world applications like this. Will drones become the tool of choice for fighting COVID-19 in large public areas? Jessica Zimmer poses that question this week in a story about the emergence of unmanned aerial systems to address the spread of coronavirus in public areas. Grand Forks, North Dakota-based SkyScopes, an industrial drone operator, well, they're studying the problem with the Center for Innovation at the University of North Dakota. SkyScopes is studying the ability of drones to disperse disinfectants in the air, both indoors and out, spraying water outside our initial tests and a 3% hydrogen peroxide solution indoors. The problem is more complex than it seems. Public areas are essentially uncontrolled, and drones will have to operate safely away from potential human contact, yet close enough to apply chemical agents with good coverage. The disinfectants themselves will have to be effective antivirals, but non-toxic, and the technology to deliver aerosols with the correct droplet size and distribution in a package small and light enough for practical use in a small, battery-powered drone, well, that's yet to be developed. Practical devices will have to have adequate flight range, a disinfectant load to match the UAV's endurance, be easy to operate, maintain, and clean, and achieve all this with safety factors necessary for flying any device over the heads of people in public areas. Systems are already used in India, and use of drones as public warning devices is also spreading worldwide, so there's reason to believe the public will accept the presence of drones overhead in public places. SkyScopes is also researching drone delivery, and the company has a parallel program to test thermal sensors in stationary locations to detect elevated temperatures in individuals. Now, there's no mention of integration of those thermal sensors into the airborne platforms, but it doesn't take a great deal of imagination to conjure drone platforms with thermal sensors and cameras beaming signals to a ground-based facial recognition system that can recognize individuals. While there would be obvious ethical questions if used for that form of surveillance, the ability to quickly and efficiently disinfect a movie theater or a concert hall before the audience arrives, or a playground before the school day begins, well, that could go a long way toward keeping the second wave of infections from spawning a third or a fourth wave. And in the meantime, the project supports the local North Dakota UAV industry, which, like many others during the pandemic, is struggling to survive. There could be autonomous drones crop dusting people in malls and sports stadiums all over America in the near future. This week, Jacob Bourne has an interesting article about a form of self-driving that's rarely talked about in this age of electric cars, and that's ocean-going vessels. Now, the world's oceans, well, they're big places, and it would seem that there's plenty of room to maneuver without banging into things. But according to the Japan Shipowners Mutual Protection and Indemnity Association's Loss Prevention and Ship Inspection Department, human error was to blame for 84% of investigated ship and harbor accidents between 2008 and 2016. Now, obviously, the insurance industry worldwide will have a real interest in maritime safety, and for the Japanese industry between 2008 and 2016, there were 2,178 insurance accidents involving coastal vessels alone, with 59% of those involving harbor and fishery accidents. Now, human injury and cargo damage accidents, they accounted for 80% of that total. 𝗘𝗡𝗚𝗚𝗘𝗘𝗥𝗜𝗡𝗚𝗚, or Class NK, well, they're a non-profit Japanese ship classification society, and they've created a comprehensive report describing the operating parameters of a workable automated ship handling system for commercial vessels. Now, setting up guidelines before the industry spends millions on research is not only a good idea, it will likely speed the introduction of workable systems to market. On land, autonomous driving systems are under development from multiple sources, but the regulatory environment and liability issues of self-driving cars on public roads are unknown. And outside of some basic SAE taxonomy, the industry framework is going to be built around whatever technology dominates. The Class NK report, a remarkably concise 50 pages long, well, it turns this on its head by driving the industry to establish a regulatory framework first. Well, the advantages are obvious. Hardware and software developers, well, they have common frames of reference this way, and with common terminology for system performance, plus a venue through Class NK to share ideas outside of government, well, that gets around that legal intellectual property framework as well. And just as importantly, the insurance industry will have a transparent and understandable way to assess autonomous ship pilotage performance systems to determine overall risk. The report estimates the systems will be ready for testing by 2025 with fairly modest automation goals. One focus will be a reduction but not elimination of human crew members for short navigation routes, while a second will be to control some ship functions remotely using offshore software or personnel. None of these problems appear insurmountable with current technology. Will the Japanese lead in maritime autonomous systems? They're using a practical, common-sense approach that minimizes risk in the search to reduce the rate of accidents to zero. We'll be watching.